Okay, so good morning, everyone. Thank you for taking a time out and joining us here today. Welcome to the third set of the CSU e-PASA Lectures 2020, hosted by the Mathematics Department of Caraga State University. This is webinars on techniques and strategies in teaching, statistics, and probability. So before we proceed, we would like to request all the participants to please follow these reminders. So have your microphones on mute. Recommend the use of laptop for this webinar. Please turn off notifications from your phone, tablet, or any gadgets. Prepare a pen or a marker and sheets of paper. Use the chat box for your questions, which will be facilitated after the lecture. So if you experience interruptions, kindly refresh the page. So at this point, let me read to you the message of Dr. Rowena P. Varela, the CSU's Vice President for Research, Innovation, and Extension. So the world was caught off guard when COVID-19 struck in the early 2020. The spread was so fast that nations around the world have to initiate quick response programs to ward off the impacts of COVID-19. After 3 months, the pandemic still continues to threaten the nations. However, people around the world start to develop adaptations to the new normal. The Caraga State University is one with the world in developing adaptive mechanisms to continue to be relevant in the new normal scenario. For one, the College of Arts and Sciences created the e-PASA program to continue to serve its clients. The e-PASA is the online version of the extension program of the college, which is the PASA, which literally means to pass on. The goal of the extension program is to pass on the knowledge in science, math, and the arts to the basic education providers in rural communities. So under the new normal scenario, the new normal approach utilizes the online platform to reduce the possibility of COVID-19 contamination by eliminating congregation in one area. Through the e-PASA, we look forward to continue serving our clients in passing on the knowledge and skills. With the new normal, we hope that this online platform would give an added knowledge to our clients by realizing that learning is possible even if threatened by disasters and diseases. So at this point, let me have the honor to introduce to you our today's resource speaker. She earned her Bachelor and Master of Science in Mathematics at Caraga State University in year 2011 and 2016. Currently, she is a faculty of Mathematics Department of Caraga State University. Please help me welcome Ms. Sheila Rae Permanes as she talks about techniques and strategies in teaching random variables and probability distribution.
Okay, so good morning, everyone. Is my voice clear? Okay, so good morning, everyone. I hope you're all doing well despite these present challenges that we are facing. And I guess you've been already slowly adjusting and preparing for what might happen come the opening of classes this August or maybe September. So for those who have been faithfully attending our webinar, the CSU e-PASA Lectures 2020, we are now down to our third set of webinars, which is on techniques and strategies in teaching statistics and probability. And for the first lecture, we have the topic random variables and probability distribution. All right, so for the senior high school curriculum, the topic random variables and probability distribution has the following learning competencies. So the learner illustrates a random variable, distinguishes between a discrete and continuous random variable, finds the possible values of a random variable, illustrates the probability distribution for a discrete random variable, constructs probability mass function of a discrete random variable and its corresponding histogram, computes probabilities corresponding to a given random variable, illustrates, calculates, and interprets the mean and the variance of a discrete random variable, and solves a problem involving mean and variance of a probability distribution. So my discussion will be focused on the mentioned learning competencies. So let us be reminded that we will be teaching this topic to our senior high school students who did not even think at this point of majoring statistics. So as much as possible, we would like to introduce to them this topic in a most basic level, getting rid of those terms or concepts which are too technical. All right, so before I will start my discussion, I would like to ask our participants first if they already have an experience in teaching statistics and probability in senior high school. I would like you to use the chat box and kindly type your answer. You may write yes if you already have an experience and no for those who do not have yet an experience. Okay, may I see your responses? All right, I have seen here a yes from Mr. Brian Anshaw. Can I hear your voice, Sir Brian? Hi, Sir Brian. Sir Brian. Can you please unmute Sir Brian? Hi, Sir Brian.
Hi,
Sir,
ma'am. Hello,
hi.
ma'am.
How are you? I would just like to ask for somehow a sharing. I would like to ask, how was your experience in teaching um, random variables and probability distribution? I mean, how did you deliver it to your students? Did you right away introduce the topic to them as just what it looks like in the book, or have you given an activity first, or anything that you have done based on your experience in teaching random variables and probability distribution?
So, morning everyone. Sa ako lang experience, ma'am, is mas nindot good if atong tagaan siya at first of real life scenario na magamit na to ang probability, ang random variable. Then maghatag tag mga scenario, then ato ipa-identify sa ila if kana ng mga scenario if pwede na as random variable.
Have you discussed them, or have you reviewed them, the concepts which they have learned in their previous grade, like
Yes,
for
ma'am.
example sample space, the random? So did you give time to give a review on that topics?
Yes, ma'am. Maybe mga 10 minutes lang.
Mhm.
Kaya na-discuss na po na nila sa ilang junior high in grade 10 ata na sa ila.
Okay. So thank you, Sir Brian.
Ma'am, thank you,
So
ma'am.
one thing is true, Gibno, this topic is really quite a challenging one. I don't know if you would agree. So
Yes.
imagine not having introduced to them the basic concepts, right? So what we can do is somewhat, in a classroom setting, by the way, in your first day of class, I guess for the first meeting, you will just give first the classroom policies, classroom rules, and then somehow give them instruction to have a review on the basic concepts necessary in learning random variables and probability distribution. So most likely for the second meeting, you will be able to test if they have reviewed their lessons or previous lessons. So, but if you do not do that, or you do not have time, you want to right away start with the topic random variables and probability distribution, then no problem, right? So I have here a suggested um, method, somehow a strategy in checking if they have reviewed their previous lessons. So this is a thought experiment. I don't know if this may stimulate their minds somehow. I don't know if some of you have already watched or seen this or used this video It can be seen on YouTube. It is called The Last Banana. This is from TED Ed, which is created by Leonardo Baricello. So as I play this video, I would like you to pay attention, and then please lend your ears because I might ask you questions later on.
You and a fellow castaway are stranded on a desert island, playing dice for the last banana. You've agreed on these rules. You'll roll 2 dice, and if the biggest number is 1, 2, 3, or 4, player 1 wins. If the biggest number is 5 or 6, player 2 wins. Let's try twice more. Here, player 1 wins. And here, it's player 2. So who do you want to be?
All right. So the question is, who do you want to be? So before I'll ask you that question, I'll mention again the rules. So they were arguing for the last banana. Who would get the last banana? So the rules are, first they will roll 2 dice. And then, if the bigger number of the 2 upturned faces is either 1, 2, 3, or 4, then player 1 wins. But if the bigger number of the upturned faces is 5 or 6, then player 2 wins. So again, the question is, which player will get the last banana? Is it player 1 or is it player 2? All right, I will launch a poll and then kindly choose your answer from the poll. Just click your answer, choose your answer from the poll, and then after your answer, you may close the poll. Okay, so 9 have answered already. How about the others? Sixteen, 17. Maybe some are still computing. How about the others? We only have 22 participants who answered. Right, 24. How about the others? Please choose your answer. You may guess. What happened to the other participants? $25. How about the others? 28. Nine. Okay, so 10 seconds left. All right, so 29 out of 48 attendees keyed in their answers. Now I will end now the poll and I will share to you the results. Right, so 62% answered player 1 will get the last banana, while so that is equivalent to 18 participants. And on the other hand, 38% answered player 2. So there are 11 participants who chose player 2. All right, so let us now find out the answer. You ready?
At first glance, it may seem like player 1 has the advantage, since she'll win if any one of 4 numbers is the highest. But actually, player 2 has an approximately 56% chance of winning each match. One way to see that is to list all the possible combinations you could get by rolling 2 dice, and then count up the ones that each player wins. These are the possibilities for the yellow die. These are the possibilities for the blue die. Each cell in the chart shows a possible combination when you roll both dice. If you roll a 4 and then a 5, we'll mark a player 2 victory in this cell. A 3 and a 1 gives player 1 a victory here. There are 36 possible combinations, each with exactly the same chance of happening. Mathematicians call these equiprobable events. Now we can see why the first glance was wrong. Even though player 1 has 4 winning numbers and player 2 only has 2, the chance of each number being the greatest is not the same. There is only a 1 in 36 chance that 1 will be the highest number, but there's an 11 in 36 chance that 6 will be the highest. So if any of these combinations are rolled, player 1 will win. And if any of these combinations are rolled, player 2 will win. Out of the 36 possible combinations, 16 give the victory to player 1, and 20 give player 2 the win. You could think about it this way too. The only way player 1 can win is if both dice show a 1, 2, 3, or 4. A 5 or 6 would mean a win for player 2. The chance of one die showing 1, 2, 3, or 4 is 4 out of 6. The result of each die roll is independent from the other, and you can calculate the joint probability of independent events by multiplying their probabilities. So the chance of getting a 1, 2, 3, or 4 on both dice is 4 out of 6 times 4 out of 6, or 16 out of 36. Because someone has to win, the chance of player 2 winning is 36 out of 36 minus 16 out of 36, or 20 out of 36. Those are the exact same probabilities we got by making our table. But this doesn't mean that player 2 will win, or even that if you played 36 games as player 2, you'd win 20 of them. That's why events like dice rolling are called random. Even though you can calculate the theoretical probability of each outcome, you might not get the expected results if you examine just a few events. But if you repeat those random events many, many, many times, the frequency of a specific outcome, like a player 2 win, will approach its theoretical probability. That value we got by writing down all the possibilities and counting up the ones for each outcome. So, if you sat on that desert island playing dice forever, player 2 would eventually win 56% of the games, and player 1 would win 44%. But by then, of course, the banana would be long gone.
Okay, so who were tricked with the question? So quite a few. So that way, it will help our students recall the following concepts necessary in learning random variables and probability distribution. So that thought experiment will help you check if they still have the knowledge on those concepts, such as the random experiment, random process, which is an experiment that can be repeatedly done under the same condition. So for the video that I have shown earlier, the random experiment or process was rolling two dice. And for the sample space, which is the list of all possible outcomes in the random experiment. So in the previous video, they rolled two dice and the possible outcomes are 1, 1, 1, 2, 1, 3, and so on, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So there's 30 possible outcomes. Also, we have the event, which is a subset of the sample space. So in the previous video, they have the event of getting 1, 2, 3, or 4 as the higher number or bigger number in the two upturn phases. Or another example is the event of getting doubles in getting two dice. So we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So we also have the probability, so which is the possibility or chance that the event or that an event will occur. So in the previous video that I have shown, so they have the probability of getting either 1, 2, 3, or 4, which is equal to only 16/36. So they used classical probability in computing, which is the number of favorable outcomes over the number of possible, total number of possible outcomes. So the probability is 20/36 in getting, or for the event of getting 5 or 6 as the higher number. So for the other example, probability of getting doubles, we have 6/36 or 1/6. Now, you may opt to extend your time in reviewing these concepts to them if you think that your student has difficulty in absorbing lessons. So you may extend your review on these concepts. Now, we are now ready to introduce the topic random variables and probability distribution. So before we introduce the definition of random variables, I would like to give, somehow you also do this in your class, I guess. So let's have a introductory discussion which will lead to the definition of random variables. So we have here a very simple random experiment, which is flipping or tossing of a coin. So when we toss a coin, what are the possible outcomes? We have what? We can have either a head or a tail. How about increasing the number of coins? Let's say we have two coins. So in flipping coins, what are the possible outcomes? So first, you flip the first coin, and then it will have an outcome of either a head or a tail. Now for the second coin, if the first coin landed on a head, then the second coin may still land on a head or a tail. Also, if the first coin landed on a tail, still the second coin may land on a head or a tail. So for our final outcomes, we have here, using this illustration on the left, we have head, tail, head, and tail. So we have 4 possible outcomes in flipping 4 coins. Now let's add again another coin. So we now have 3 coins. So here is the diagram. We have the results for the first coin, the second coin, and the third coin. So we now have how many possible outcomes? We have the outcomes head, tail. What else? On the third one, we have tail, head, tail, head. And then the fourth one, head, tail, tail. And then the fifth one, tail, head, head. We also have tail, head, and then tail, 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 and tail. No, tail, tail, head, and tail, tail, tail. So there are 8 possible outcomes. So if we are going to write the possible outcomes of those mentioned random experiment, we have here the sample space in flipping a coin, which is head tail. So our S now, so our students already know that the sample space is denoted. So as you review, you may mention to them how we are going to write the sample space and its elements. So S now is equal to HT. And for flipping of 2 coins, we have the 4 possible outcomes, HH, HT, TH, and TT. And for the flipping of 3 coins or tossing of 3 coins, we have here the 8 possible outcomes. Now, I am interested on the third random experiment, which is flipping of 3 coins. So notice that the possible outcomes in flipping 3 coins are the following. We have mentioned that earlier. So let us enclose these outcomes in a rectangular box. Now suppose there is a characteristic of the outcomes that I am interested of. Let's say number of heads. Now let us assign numbers to these outcomes. So how are we going to assign these numbers to these outcomes? So of course, we'll just have to count the number of heads in each outcome, which means that for the particular outcome HHH, we have 3 since there are 3 heads. And for HTT, we have 1. For THH, we have 2. HHT, we have still 2. THT, 1. HTH, 2. TTH, 1. And TTT, 0, since there are no heads in the outcome TTT. Now, how about, let's have another characteristic of the outcome, which is the number of tails. Now, what happens to these assigned values if we are interested in the number of tails in the outcomes? Right? I'll launch again a poll. I would like to ask you, suppose you are my students. Okay, so will it remain this? Will these values remain the same, or will these values change? Okay, choose your answer for the poll. So I am referring to the values assigned to the specific outcomes, to each outcome. Suppose for the number of heads, the assigned value in the specific outcome THH is 2. Will it remain the same or change if I'm now interested for the number of tails? How about the other participants? There's still other participants who haven't answered yet. $35, $36. How about the others? $38. Okay, so last 10 seconds. All right. So let me end the poll. Share to you the results. By the way, if I continue with my slides and then the poll, the result of the poll is still appearing on your screen, you may close it. So we have 60% answered the values will remain the same. And 43% answered the values will change. So by the way, I am referring to the values assigned for each specific outcome, not the values in general. So let us now find out the answer. So if this particular outcome HHH has the value 3, if we're interested in the number of heads, do you think it will still be 3 if I will choose another characteristic, which is the number of tails? So the answer would be what? Letter B. The values would change. So this HHH, I understand if some of you might took the question differently. So this particular outcome HHH now will have a value of 0 since there are no tails on the specific outcome, right? And for HTT, it will have a value of 2 since there are 2 tails. And for THH, it will have a value of 1. HHT, only 1 tail, still 1. THT, 2 tails. HTH, 1 tail. And TTH, 2 tails. And TTT, you have 3 tails. So the values assigned to these numbers, the values assigned to these outcomes, the specific outcomes changed. All right? So if you notice, if our variable of interest is the number of heads, this particular outcome is assigned with 1. On the other hand, if our variable of interest is the number of tails, then the same particular outcome, THT, will now have a different assigned number, which is 2. So let's look at all the outcomes. Let's go back to all the outcomes in flipping 3 coins. If we are interested on the number of heads, so the values are 3, 2, 1, and 0. So our HHH is assigned to 3, HHT is assigned to 2, HTH is assigned to 2, HTT 1, THH 2, THT 1, TTH 1, and TTT 0. So if we let the number of heads be equal to our X, that means now that the values of X can be 0, 1, 2, or 3. And that is now our random variable. Okay, so our random variable has 2 definitions. The first one is an intuitive definition, while the other one is a mathematical definition. So how I illustrated it is somehow intuitive. So a random variable is a variable with numerical value that can take on or represent any possible outcome in a random process or experiment. While for the mathematical definition, it is a random variable. A random variable is a function this time. If you notice, I have mapped the sample space to the number or the possible values of our random variable. So it is a function from a sample space S into the real numbers, right? So let us have here points to remember. A random variable is represented, if you notice, I used capital X. So a random variable is represented by an uppercase letter such as X. But you can still also use other uppercase letters such as Y or Z. while its corresponding letter or corresponding lowercase letter represents one of its values. So for example, if our random variable is the number of heads, so that means the capital X. That means our small or lowercase x will assume the values 0, x may be equal to 1, equal to 2, or equal to 3. The value now associated to an outcome depends on the random variable itself. So that's why that was what I asked you a while ago, if the values will change or if the values will remain the same. So in example, in tossing 3 coins, if the random variable x is equal to the number of heads, then for the specific outcome THT, x is equal to 1. On the other hand, if the random variable x is equal to the number of tails, then for the outcome THT, our x is equal to 2. Okay, so that was our definition of random variable. So this time, I have another thought experiment which will lead to the introduction of the different types of random variable. Okay, so if you are going to roll a die, how many possible outcomes are there? I am referring to a regular die. So how many possible outcomes are there? So the cube-shaped die has 6 possible outcomes. So there is exactly 1, exactly 2, exactly 3, exactly 4, exactly 5, and exactly 6. Now, can we get a 1.3 or a 2.7? Or how about a 3.5? Of course, the answer is a big no. There are no in-betweens, only 6 possible outcomes. Okay, so please take note of this first question. How about here? If you are to measure the weights in kilograms of randomly selected whole chicken in a supermarket, how many possible outcomes can you get? Can I call one participant? Can I ask Mr. Christian Salazar? Hi, Sir Christian. Can you please unmute Sir Christian? Christian Salazar. Missing si Sir Christian. Sige, let's have... nara si Sir Christian. Ay, nawala din si Sir. Okay, let's ask Ma'am Saibil Olaybar. Sige daw, si Ma'am Saibil Olaybar. Ma'am Saibil. Can we please unmute Ma'am Saibil? Sir Junar, Ma'am Kay.
Yes, ma'am.
Okay, can you please unmute Ma'am Saibil Olaybar?
Okay, sige. Unmute ko.
Oh, what's happening? Muted. Okay, so let's do that later na lang. So if you are to measure the weights in kilograms of a randomly selected whole chicken in a supermarket, how many possible outcomes can you get? So one possibility could be, let's say, 0.97 kilograms. Or another possibility is 0.973 kilograms. or 0.9735 kilograms, or 1.002 kilograms. So that means, what does that mean? It could be any value, actually infinitely many possibilities. And if we are to put these values in a die, let's say we'll try to change the number of sides of a die, what would the die probably look like? So let's consider the weight from 1.001 to 1.1. So we have there 10 possibilities. Just 100 possibilities only for the interval 1 to 1.1. So it might look like this, a 100-sided die. And how about increasing it? So from 1.00 to 1.0001 to 1.1. Then that will be 1,000 possibilities. So if you're going to put that numbers or values in a die, it would probably look like this. So most likely, it has numerous sides and it will look like a sphere, diba? So these two questions now will lead to the types of random variables. This thought experiment or this introductory discussion will lead to the definition of the types or the types of random variables. So we have the discrete random variable, which is described using the first question. So a random variable which may take finite number of distinct values or a countably infinite sequence of values. So we have no problem there with a finite number of distinct values. We have here countably infinite. So infinite, but it is countable, meaning you can put it in a one-to-one correspondence with the set of natural numbers. So let us say you do not know the last element or the last possible value of the random variable, but you know that there will be a last. Okay, so example, let's look at these examples to better understand it. So X is equal to the number of items answered correctly in a 5-item quiz. Another example is Y is equal to the number of lottery tickets purchased until the first winning ticket. Okay, so for the X equal to the number of items answered correctly in a 5-item quiz, of course, our random variable may take 0 in the case that no question is answered correctly. So 0. It can be 1 also, it can be 2, it can be 3, and it can be 5. Can it be 6? So impossible. So our X now has values 0, 1, 2, 3, and 5. But how about the number of lottery tickets purchased until the first winning ticket? So of course, you will not win if you will not purchase one. So the least number or value of the random variable is 1. Of course, we'll start with 1. And then if the ticket didn't win, then we'll purchase another one. But we do not know the last entry, right? Because we do not know when will be the winning, when we're going to get the winning ticket. So we're just going to write like that. Y is equal to 1, 2, 3, 4, ... So that means it is countably infinite, okay? We can put it in a one-to-one correspondence with a set of natural numbers. Now, for the second question I posted earlier, we have the continuous random variable, which is a random variable that can assume infinite number of values between two specific values. If you recall, I have mentioned 1.0001 to 1.1. Okay, so we have two specific values. We may also have 1 to 2. So we can get infinitely infinitely many numbers or values between 1 and 2. So examples are weight in pounds of newly born babies in a hospital. And we also have temperature of a cup of coffee served at a restaurant, right? So for our X and Y, of course, it can assume infinitely many values. For the possible values of X, imagine the values just in between 6 and 7 pounds. So that can be 6.0001, 6.0005, 6.1253, and so on. Same goes with the possible values of our random variable Y. Okay, so we are now down with the types of our random variable. So we have points to remember. Values that can be assumed by a discrete random variable are whole numbers and are often results of counting, while the values that can be assumed by a continuous random variable are infinitely many. It can be any value, including all decimal values, and are often results of measurement. All right? So let's have a quick test this time. Okay, here comes the ball. Here are the questions. Determine if the random variable X or Y is a discrete or continuous random variable. For number 1, X is equal to the number of loans applied by a randomly selected teacher. For number 2, Y is equal to the average amount spent in electricity in the month of July of Barangay Ampayan residents. And number 3, number of courses a randomly selected student is taking. So launch the poll. All right, choose your answer for questions 1, 2, and 3. And if the box or the poll is blocking the slide, you may drag it sideways if you want. Okay, 34 out of 43. How about the other remaining participants? Okay, so let's now end the poll. Okay, and let me share the results of the poll. So for the first random variable, number of loans applied by a randomly selected teacher, 93% answered discrete, while 3 participants or 7% answered continuous. So the number of loans applied by a randomly selected teacher. For number 2, the average amount spent in electricity for the month of July of Barangay Ampayon residents. So we have 2% answered discrete, while 98% answered continuous. And for the third random variable, X is equal to the number of courses a randomly selected student is taking. 98% answered discrete, while 2% answered continuous. So let's find out the answer for the question. So X now equal to the number of loans applied by a randomly selected teacher is what? Of course, it's a discrete random variables. Kinsa may mga nag-loan diri Okay? Pila man inyong number of loans nga gi-apply? Nabay 1.5, Nabay 1.3. Kay gamay ra inyong nakobra. So, of course, so you can count it. So, naay 1 nga number of loans, naagi 0 number of loans. Kaya di ganahan mag-loan si ma'am or si sir. Kaya gusto niya hinlo iyahang sweldo. So, for the Y equal to the average amount spent in electricity in the month of July of Barangay Ampayan residents. So, unsa inyong na-observe sa atong bill sa kuryente? Does it have decimal numbers? Diba na ano? So, it is a continuous random variable. And for the last one, we have number of courses a randomly selected student is taking. Number of courses. So that means you can take math, English 101, and so on. So no, wala man siguro yung course na kung ano, 0.5 or 0.3 or 0.2 or 0.1. So most likely, na siya 9 ka courses, enrolled ron, and so on. So this is a discrete random variable. So those are for the types of random variables. Okay, so this time, let us go back to the experiment of flipping three coins. Okay, so this is for another topic na po. How many possible outcomes are there? If you can recall, 8 possible outcomes, right? Now, this S has 8 possible outcomes, and we are going to map it with the number of heads, which is random variable X. So, unsa gani to iyahang mga values? We have 3, 2, 1, and 0. The values can be 0, 1, 2, or 3. And that means we can write it down on a table. Okay, so naatay table diri on the left, which gives the values of the random variable on the first row. So what can we write on the second and third row? So for the second row, let's have the number of favorable outcomes. For example, kung 0, what are the outcomes associated with 0? That is only TTT. So there is only one favorable outcome. For the random variable X equal to 1, the only favorable outcomes are HTT, what else? THT and TTH. So that is 3. And for the X equal to 2, the favorable outcomes, we have 1, 2, and also 3. And for the random variable X equals 3, we have only 1. Okay. So atong third row this time, we'll get the probability of a random variable. And how are we going to get that? So our students already have learned the concept of probability, right, in their previous grade. So we may recall it. So we are going to use the classical probability this time. So for the classical probability, we have number of favorable outcomes over the number of possible outcomes. So for X equals 0, our number of favorable outcomes is only 1. And the number of possible outcomes in flipping 3 coins is 8. So we have here 1 over 8. And for X equals 1, our probability is 3 over 8. And then for X equals 2, still 3 over 8. And X equals 3, still 1 over, also 1 over 8. So pwede din nato siya no nga ibutang ang mga probabilities niya. Pwede din nato makuha ang probabilities associated with our random variables. Right? So for the random experiment of flipping 3 coins with random variable X equal to the number of heads, we can represent the probabilities of these random variables using a table. And this is now called, if you observe, I have omitted the second row of the previous slide. Somewhat guide lang to siya sa ato ang mga students, okay? In getting the probability of a random variable. So usually our table looks like this. First row for the number or the possible values of a random variable, and then the second row is the probabilities of a random variable. So that is the probability distribution of a discrete random variable, which is represented or which is described using a probability distribution table. Okay. So that is now the probability distribution table. If you notice, look at the table, the probability of each value of a discrete random variable is between 0 and 1 inclusive. So, di ba, kani. So we have 1, 8, 3, 8, 3, 8, 1, 8. Okay, so we have 1, 8, 3, 8, 3, 8, 1, 8. That is, our probability of x is greater than or equal to 0 or less than or equal to 1. So if we are going to represent it using a rectangular blocks with a rectangle with an area equal to 1, so this probability associated with x equals to 0 only takes this part of the rectangle. And for the probability of x equals 1, which is 3, 8, it only takes this part of our rectangle. So kaniya tong rectangle, ang area kibaliani 1. So kadtura ang iyahang part, which means it's smaller than the rectangle. So that means it's less than 1, right? Now, also, the sum of all probabilities is equal to 1. That is the summation. So this symbol, you may also want to include this in your review. So the summation of the probability of x is equal to 1. So for distribution, probability distribution table above, we have the summation of our p of x is equal to p of 0, probability of 1, probability of 2, plus probability of 3. So that is equal to 1, 8, plus 3, 8, plus 3, 8, plus 1, 8. That is equal to 1. So if we are going to represent it using this again, a rectangle, so our probability of 0 is 1, 8. So since there are 8 parts, so we will divide it into 8 equal parts. So 1, 8 plus 3, 8 plus 3, 8 is plus 1, 8 is equal to 1. Okay. So, so in summary, the properties of a discrete probability distribution, the probability of each value of a discrete random variable is between 0 and 1 inclusive. And the sum of all probabilities is equal to 1. Okay, so it's your turn this time. Using the properties I have mentioned in my previous slide, determine which of the following is a discrete probability distribution. We have letter A, this table, letter B, this table, and letter C, this table. Okay? All right. Si Piat, si Ma'am. Okay. So let me launch the poll. Already on the fourth poll. Okay. So for our bonus na si Wano kay na ni Ma'am. Okay, so letter B and letter C. Please choose your answer. Okay, 11. How about the others? 19, 20. $25. 29. Okay, 20 seconds left for the other participants. Right, 33 lang ang nag-answer. 34, 35, 36. Okay, let me end now the poll. And share to you the results. Okay. So for the first table, 81% or 29 participants answered letter A. Letter A, discrete probability distribution. And 7 or 19% answered what? Not a discrete probability distribution. Okay, unsa kaha ang correct answer ani? For number 2, you may check the two properties. So the first property is the probabilities sa each random variable is from 0 to 1 inclusive. That means it can be 1 or it can be also 0. And then the second is the sum. If you get the sum of all the probabilities, it will be equal to 1. And for letter B, we have 36% answered it is a discrete probability distribution. 13 participants answered. And 64% answered it is not a probability distribution. So again, check the two properties. Asa siya nabikil. And for the third, we have 94% answered not a discrete probability distribution. And two participants or 6% answered it is a discrete probability distribution. This time, I'd like to call a participant. Please, you can unmute yourself if I'll call your name. Okay, akong balikan si Ma'am Sybil Olaybar. Hi, Ma'am Sybil. You can unmute your microphone. Please unmute your microphone, Ma'am Sybil. Okay. Hi, Ma'am.
Hi, ma'am.
Sunlight. What's the answer ni mo diri as the letter A, ma'am? Is it a discrete or not a discrete probability distribution? What's your answer?
Kaano, ma'am?
The two properties that we have mentioned earlier. Sige, so good ka sa iyahang value sa probability. Naabay nilapas mas niubos sa 0 or mas nisaka kaysa sa 1 sa ilahang upat? Check the probability. Naa o wala? 2/7, 2/7. Kinsa may mas niubos dira kang 0 or mas nilapas kang 1? Kinsa man? Naa o wala? Si 2/7, 0 and 1, di ba? Inclusive. Si 4/7, is it between 0 and 1? Yes or no? Kinsa man, ma'am?
No.
Okay. Ha? Dili siya between 0 and 1? Si 4/7?
Between, 0 ug 1. Between, ma'am.
Okay, very good. And for 2, probability of 2,
Bet-
0 over 5.
bet- between
Diba? Or equal to 0 siya. And si 3, 1 over
0.
7, between gihapon.
Between.
Oh. And
So, discrete siya, ma'am.
pag gani ka na human, second. Diba?
Awa pa
Ano
din,
yung
ma'am.
second property, diba? Unsa man ang second property? Kung daw siya add tanan, mo sum up dapat siya sa 1. So, 2 over 7 plus 4 over 7 is 6 over 7 plus 1 over 7, pila man na? Pila
7
na
over 7.
Alright, so, iyahang sum is
1.
So,
1.
what's your answer now?
Discrete, ma'am.
Okay. Hi, Bill. Thank you for participating. Congratulations. How about for letter B? Where is Sir Jezreel daw? Hi, Sir Jezreel. Pwede ka mag-mute, please? Jezreel Valdueza. Hi, Sir Jezreel. Are you there?
Yes, ma'am.
Sir Jezreel, answer mo for letter B. Is it a discrete probability distribution or not?
Ma'am,
Answer nito sa letter B. Katong imuhang answer sa poll gaina.
pwede ko baka-review sa question, ma'am.
The question is,
is...
determine which of the following is a discrete probability distribution. Is this table here in letter B a discrete probability distribution? Di ba ang first property for a discrete probability distribution is the values or the probabilities for our random variables must be between 0 and 1, inclusive. So, iya bang nasatisfy ang property number 1? Wala ba'y nilapas dira akang 1 or niubos kang 0? Naa.
Ako sa ma'am, kay naglibog ka niya akong account, ma'am. Kaya ako makita sa screen.
Okay.
At sa, kaya naglibog ko ask tong question.
Okay.
Kaya mong diso. At sa, ask mo ni. First time lang ako nagkuhan.
It's okay, sir.
Asa mo?
How about...
Ikaw lang ako makita.
Dili mo makita, sir. Okay.
Wala yung presentation.
Let's ask for a rescue. How about Sir Rocky? Sir Rocky Gonzaga. Pwede ka mag-unmute, sir?
Yes, ma'am.
Okay. Hi, sir.
Hi, ma'am.
Okay, what's your answer for letter B, sir? Is it a discrete probability distribution or not?
Discrete probability, ma'am.
Okay, check number 1. Ang tanan ba nga values niya kuan between 0 and 1 inclusive? Yes or no?
Yes, ma'am. I-add ata na 1 man.
Dili, i-check pa natong isa-isa first. Si 1 over 10 is between 0 and 1, di ba? 3
Yes.
over 10, 1 over 5, 2 over 10, 3 over 10.
Yes.
How about, so iyahang na-satisfy, first property is satisfied already. How about the second property? If you're going to add this, will it be equal to 1?
Ma'am, that is equal to 1. That is 10 over 10.
Really? Sige daw. True ka daw, sir. 1 over 10 plus 3 over 10 is 4 over 10. Diba? So, 1 over 5. Pila man na siya. Kung himuon na to na siya 10 ang iyahang denominator, that is 2 over 10 siya, diba?
Yes.
Okay, so 2 na ni siya diri. So, 1 plus 3 plus 2, 6.
Yes.
Plus 2, 8 plus 3, 11 man, sir.
So, di wala sinasatisfy in second.
Oh, yes, sir. So, it is now, unsa man, discrete probability distribution or not?
Not discrete, ma'am.
Okay, very good. So, property number 2 is not satisfied, right? So, dili siya discrete probability distribution. Thank you, Sir Rocky. And for the third, letter C, Si Ma'am, let's have a girl this time. Ma'am Josefina Tabat. Pwede ka maka-unmute, Ma'am Josefina?
Yes, ma'am. Good morning.
Hi, good morning, ma'am. Kumusta? What is your answer for letter C, ma'am?
Not, ma'am.
Okay, so unsa ato nga property ang iyahang wala na satisfy, ma'am?
Property number 2, ma'am.
Alright, so ang iyahang property number 2, unsa day ang property number 2? Iyahang sum is equal to 1. Alright.
Na-exceed man siya og 1, ma'am.
So that means appeal po di IC property 1. Kay kani di IC 3,
Yes,
di ba?
ma'am. Kay 1.1 and 2, kay ang isa is 1 point, dili na siya between 0 and 1.
Okay, so very good. Thank you kaayo, Ma'am Josefina.
Yes,
Salamat. Okay, so inganaon na nato no pag-determine if you're given a probability distribution. Check the two properties to determine if it is discrete or not, right? So this time, so motto si letter A, discrete probability distribution, letter B, not a discrete probability distribution, and letter C, not a discrete probability distribution. All right. Now, let's look at again this probability distribution right here. Pwede di ay nato ni siya nga i-transform into a graph. Okay? So, pwede di ni siya himuon nato og graph or chart. And this chart is a probability histogram. What is a probability histogram? It is a histogram, of course, the one that we taught our students for the frequency distribution table, di ba? Na histogram ato niya. So a histogram with values of the discrete random variable on the x-axis. So if you notice the x-axis, muna siya dira ang values sa ato ang random variable. And for the y-axis, we have the probabilities. So that is a probability histogram. Now, usually, on a classroom setting, nga mag-face-to-face ta sa atong students, when we ask them to draw a probability or to construct a probability histogram, they will just have to draw it on their paper, right? So, dili na kinahanglan, no need of help sa computer or sa unsa na diraa nga aid. But this time, di ba, online naman daw. So most likely, siguro if it is asynchronous, which means the learning is based on the flexibility of the student, we can have a pre-recorded video, right? So ato na lang i-illustrate sa ilaha kung unsaon pag-construct ang probability histogram using an Excel. Okay. So, pero if magpa-activity na ka sa ilaha, pwede ra sa ato mangong LMS, they will be allowed to submit a written. Ila lang picturean and then i-send dayon, i-upload dayon nila. But let's say gusto lang gid ta tudloan atong student unsaon pag-construct og probability histogram using Excel, so we can teach them. Okay? So let's watch this video unsaon pag-construct og probability histogram. Ako nang gi-record daan akong illustration. So in your Excel, just type the values of a random variable. So in our example, we have the value 0, 1, 2, 3. And then for the probability of our random variables, we have p of x. So for x equals 0, we have 1 over 8 in our example. So if we're going to type 1 over 8, we'll have an output like this. It will become a date since the number here is general. So instead, we type first 0 and then space 1 over 8, and you will have fraction. Then for x equals 1, the probability is 3 over 8, so 0, space 3 over 8. And then also
Also for x equals 2, 0 space 3 over 8. And then for x equals 3, 1, 8. So 0 space 1 over 8. We'll just highlight all of these values here, including the p of x, and then choose charts, choose the column, and then clustered column. Okay, so you will have an output like this. Now change its setting or layout to this layout here. And then, so that you will have distinctions between the bars. Click the bars, then choose the format, and then pick a color which is darker. So that's better. And then for the axis title, you will have the x-axis is the random variable. For the y-axis is what? Probability. And change also the chart to probability histogram. Okay, so if you notice, the values here in our x are 1, 2, 3, and 4, but our random variables are 0, 1, 2, and 3. So let us change this. You click the values and then you go to chart layout, charts, and then select, and then you choose the category X labels, then highlight these values here, and then click OK. So now it's changed already to 0, 1, 2, and 3. And for this vertical value axis here, so the number 0 is repeating, so let's change that. Let's go to the chart layout. So since we already clicked this, so it's the vertical value axis. Let's format the selection and then choose the scale. And then for the major unit, you change this to 0.125 since 1 over 8 is equivalent to 0.125. 0.125. So that's it. You already have your probability histogram.
Right. So that's the probability histogram in Excel. So let us have another example here. Suppose you are going to roll 2 dice and let X be the sum of the upturned faces when you roll 2 dice. So let's construct a probability distribution table and probability histogram for our random variable X. So our random experiment is rolling 2 dice and our random variable X is the sum of the upturned faces. Okay? So our possible values in rolling 2 dice, so the first die can land on 1, 2, 3, 4, 5, or 6, and the second die can also land on 1, 2, 3, 4, 5, and 6. So the possible outcomes now are the following. Kana sila 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on. So nasa ato ang mga rows. But we are not interested with that, di ba? We are more interested of the random variable X, which is the sum of the upturned faces. So if we are going to add these values 1, 1, 1, 2, 1, 3, and 1 and 4, 1 and 5, 1 and 6, so you will have this sum. So 2, 3, 4, 5, 6, 7, and another for the second row, 3, 4, 5, 6, 7, and 8, and so on. So the least sum is 2, and the greatest sum is 12. So that means our random variables now will have the values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So for the outcomes nga naisang nga 2, that is only 1, 1, right? So if we'll get the probability, since we have 36 possible outcomes and only 1 favorable outcome, so using the classical probability, we have the probability equal to 1 over 36. For the sum equal to 3, we have the outcomes 1, 2, and 2, 1. So we have the probability 2 over 36. For the sum equal to 4, we have the outcomes 1, 3, 3, 1, 2, 2. So we have the probability 3 over 36. For 5 over 5 nga sum, we have the outcomes 1, 4, 4, 1, 2, 3, 3, 2. So we have the probability 4 over 36. And for 6, we have 5 possible outcomes or favorable outcomes. So we have 5 over 36. And for 7, we have 1, 2, 3, 4, 5, 6 favorable outcomes. So you have a probability of 6 over 36. And for 8, we have 5 favorable outcomes. So we have 5 over 36. For 9, 4 favorable outcomes. We have 4 over 36. And for 10, we have 3 favorable outcomes, so 3 over 36. For 11, 2 favorable outcomes, so we have 2 over 36. And for 12, we have 1 favorable outcome. So we have the probability of the random variable 12 equal to 1 over 36. So if we construct now a probability distribution table, we'll have a probability distribution table that will look like this. But some of the probabilities can be reduced. Some of the probabilities can be reduced to lowest term, just like the 2 over 36, 3 over 36, 4 over 36, and so on. So we can have these values. So 1 over 18, 1 over 12, 1 over 9, 1 over 6, and so on. Okay, so for its probability histogram, you will have this. So if imong i-follow tong Excel nato dito mo ni siya ang itsura sa iyahang probability histogram. Okay? All right. So now let's go back to the outcomes in flipping 3 coins. So we have the outcome here mapped to our set of random variables, which is 3, 2, 1, and 0. Now, di ba naatay probability distribution table, di ba? So unsa to ang mga probabilities sa ato ang probability distribution table? We have 1, 8, and 3, 8 only. So let's add here 1 for the probability of our x. And ang atong elements dira is only 1, 8, and 3, 8. So kinsa may naka-map kang 1, 8? Si 3. Who else? How about si 2? Asa man siya naka-map? Ang 3, 8. Si 1 nakamap kang 3, 8, and si 0 nakamap kang 3, 8. So we now have here a function from the random variable x to the probability of our x. So we now have this. So ato ni siyang himuon, ato ni siyang buhatan og probability mass function. So it can be denoted as f of x, which is a function of x, now equal to 1 over 8 if x is equal to 0, 3 over 8 if x is equal to 1, 3 over 8 if x is equal to 2, 1 over 8 if x is equal to 3, and let's include 0 if wala dira sa listahan, right? 0 otherwise. So that is now called the probability mass function, which is also a probability distribution of a discrete random variable. Now, we may rewrite this function kay na may nagbalik-balik si 1, 8, si 3, 8, ikaduha pod. So we may write it like this. 1, 8 siya if x is equal to 0 or 3, and then 3, 8 if x is equal to 1 or 2, and then 0 otherwise. All right? So that is our probability mass function. So our probability mass function of x is denoted by f of x. And it satisfies the following properties. Number 1, f of x is just equal to the probability of a random variable x, which is greater than 0 if x is an element of the support S. Kinsa na sa support S? The set of values that random variable can take. And it is a summation, and the summation of our f of x is just equal to the summation of our probabilities of x, which is also equal to 1. So, kadtong ato ang rolling 2 dice, ang ato ang probability mass function is 1 over 36 if x is equal to 2 or 12. 1 over 18 if x is equal to 3 or 11. 1 over 12 is if x is equal to 4 or 10. 1 over 9 if x is equal to 5 or 9, and then 5 over 36 if x is equal to 6 or 8, and 1 over 6 if x is equal to 7, and 0 otherwise. Okay, so mo ni iyahang probability mass function for the random variable x equal to the sum of the upturned faces. Okay, sa iyahang probabilities. Now, we have here an example. Suppose a random variable x can only take the 4 values, 0, 1, 2, and 3. If each value has equal probability, then its PMF now is equal man daw iyahang probability, then we have 4 values. So, ang iyahang sum daw dapat is 1. So, we'll divide it by 4, which means 1/4 siya kung x is equal to 0, 1/4 if x is equal to 1, 1/4 if x is equal to 2, 1/4 if x is equal to 3, and 0 otherwise. Or simply, f of x is equal to 1/4 if x is equal to 0, 1, 2, or 3, and 0 otherwise. Actually, there are still other problems involving the PMFs. Kanilang ang ako ang introduce. So now, let's look at the probability distribution of a discrete random variable x, which is equal to the number of upturned face in rolling to die. In rolling a die, rather. So, isa lang ka die ang ato ang i-roll. So, they all have equal probabilities, di ba? So, the probability of getting a 1 as the upturned face is 1/6, 2, 1/6 gihapon, and so on. They have equal probabilities. One interesting property here is getting the mean and the variance of this probability distribution. Now, our students have already learned in their previous grade how to compute the mean and variance, di ba? So, how about this time in a probability distribution? Okay. So let's examine these values. We have 2, 2, 2, 4, 4, and 5. How do we compute the mean of these values? So if you will ask your student kung yun sa pag-compute ang mean and ang values, most probably they will know how to compute the mean. And how are we going to compute the mean? That is just adding all the values in the set, and then divide it by the number of values present. So there are 6, so we have 2, 2, 2, 4, 4, 5. So there are 6 of them. Just add the values and then divide it. So you will have 3 over 17. Another way of computing it or showing the mean is using the distributive property of multiplication over addition. So the mean, kung imo siyang isa-isahon, di ba? Okay. So, kaning si 2, pwede siya, kwaon na to, 2 over 6, bulago na to. And then, naapod tayo 2 over 6, and then plus another 2 over 6, plus 4 over 6, plus 4 over 6, plus 5 over 6, which will still be equal to 3 over 17. Or, naapay isa, which is this. Ang mean daw na to, pwede siya 3 over 6 times 2 plus 2 over 6 times 4 plus 1 over 6 times 5, which is still equal to 3 over 17. But how did we do that? Yung sama na siya. Kani si 3 over 6, kani si 2, 4, and 5, these are the unique values in our set, di ba? Natay 2, 2, 2, 4, 4, 5. Kung sa man ang mga unique values, ana? So, 2, 4, and 5. Yan sila. Gi-multiply na siya sa factor nga k over 6, where k is the number of occurrences in the value. So, asa ni nato gikuha si 3 over 6? So, 3 is the number of times that 2 appeared. So, 1, 2, 3. So, mo na siya nga to ang k, 3. Over 6, since there are 6 numbers here, right? Plus, si 4, it appeared twice. And then si 5, it appeared once. Diba? So, still, kung ingan nyo na to siyang pamaagi, you'll still get the mean. And that is now, notice that the k over 6 factor reminds us of the classical definition of the probability, right? So what is the probability of getting a 2? So imurang ipon, pila ang 2? 3. And then pila day sila kabuok? 6. So 3/6, right? So if we think of drawing a number from this collection of values, 2, 2, 2, 4, 4, 5, and then after drawing 1, you replace them immediately after, then each of the 3 unique values will have the probability of k/6 being drawn at every single child. So now, with this process, we are essentially creating a random variable out of the finite collection. And that is now the mean or expected value of the random variable. Being ato nato siya pag-compute. Okay? Kaysa i-introduce nato ni siya diretso sa atong mga estudyante, ma'am, unsa man ma'am, summation of x times p of x. Though they already know that x is the value of the random variable and p of x is the value or the value of the probability. So somehow that would help illustrate yun sa nato pag-compute. So our mean, which is also the expectation of x, is equal to the summation of our x times the p of x. So we have here, we get each value of a random variable and weighted it using the probability of the random variable, right? So ang x nato here is the discrete random variable, the uppercase x. The x, the lowercase x, is the outcome or value of the random variable, and p of x is the probability of the outcome x. Okay, so let's take a look at the experiment of rolling a die, whose sample space is a set 1, 2, 3, 4, 5, and 6, with each outcome having a probability of 1/6. So iyang probability distribution table, ingani ba ya? So ato dayon i-compute ang iyang mean or expected value. Si mean nga gitawag or gi-denote pod nga mu. Saan na to siya? Okay, si expected value is, okay, multiply our random variable x times the probability of the random variable. Mo pi na atong gibuhat kagaina sa kadtong wala patan gi-introducean sa formula sa ato ang mean sa random variable. So we have 1 times 1/6 plus 2 times 1/6 times 3 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. And that is 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. That is equal to 21/6 or 3.5. So natay mean na 3.5. So unsay pasabot ayaw? Unsa man ang mean, ma'am? The mean now is the weighted average of the values, not the arithmetic mean that we have taught our students sa iyang previous grade. Our mean or expected value now is the weighted average of the values that x can take, with weights provided by the probability distribution. So, for one thing, that means if we roll a die repeatedly in increasing number of times or repeatedly do it over and over again, its mean will converge to 3.5. Okay? Kung mag-roll ta og die kapila, balik-baliko na to, and then kaon na to ang iyahang mean, mo converge yun na siya sa 3.5. Okay? So hence, it is referred to also as the long-term average. Mo to siya si expected value, the expectation of x. That is the long-term average. So if mo roll ka og die 250 times, if kwaon nimo na ang mean atong iyang outcomes, it will converge to 3.5. Kuha na pug ka og 100 mag-roll na pug ka 100 times, maura gihapon. And if you do it increasing repeatedly in increasing number of times, still it will converge to 3.5. So now this time, it's your turn. What is the mean or expected value of x given the probability distribution below? All right. I hope you have your pen and paper with you. Sige daw, kamud daw. Please compute the mean of this or the expected value of a random variable x given the probability distribution. And then you can write your answer in the chat box. Sige, let's have 1 minute. It's 10:37. Okay, 1.12, 1.28, 1.12, 0.32. Okay, how about the others? What's your answer? 1.12. Okay, sige daw, B. Actually, nag-poll ko. So, tanawon daw nato ang uban. Sige, pick your answer. By the way, for the webinar tomorrow, we encourage you to use your laptop for the remaining webinars. Kay helpful gid kaayo kung mag-laptop ta. And then also, magamit po daw mo og calculator. All right. So 95, let's end out the poll, and we have 95% answered 1.12 and 5% answered 1.28. Right? So 0, unsa ganitong atong mga distinct values, 0, 1, and 2. So 0.16 times 0 is 0. 1 times 0.48 is 0.48. 2 times 0.32 is 0.64. So 0.64 plus 0.48 is equal to 1 over 12. So the answer is 1.12. Sorry. Right? So sayon ra siya no. Dili na maglisod atong bata. Naon lang nato, pwede nato siya hatagan og probability distribution table, then dali ra kayo ang pattern pagkuha sa iyahang mean. So this time, let's have the variance of a discrete random variable. Recall that the mean or expected value of our discrete random variable is given by this formula, right? Okay, so the summation of our x times p of x. This time, the variance is the expected value of the square of the difference between the assumed value of the random variable and the mean. So, x minus mean or mu, kwaon daw nimo iyahang square, kwaon nimo ang iyahang expectation. So, ingon ani iyahang itsura. Variance of x, denoted by this symbol, or also sigma squared, pareho ra na siya, is the expected value of the square sa maggamit sa kuog spotlight. Okay, so is the expected value of the square of the difference between the assumed value of the random variable and the mean. Kwaon day nimo iyang expected value? Unya unsa ganitong expected value? The summation. The summation of kung extra ni siyang na diri extra po datong ibutang diri Unya kay x minus mu or mean squared man siya. So that means ulihan po nato ni siya diri og x minus mean squared. Right? So muna siya ang relationship ni mean ug variance kung tan-aw nato ang iyang formula. So kung kwaon nato ang iyang summation, yun ani iyang itsura. Ba? So kung kwaon nimo ang iyahang kung imuha ni siyang, we are going to square this value here, and you square that out and carry the expectation through, then this can be shown to be equal to this one. So naakay summation of x squared times p of x minus algebra, gamitan na itong algebra. Summation of x squared times p of x minus the summation of x times p of x quantity squared. Kinsa gani ning summation of x squared times p of x? That is the expected value of x squared or the mean of x squared. Minus, kinsa gani ning naa sa sulod diri asa b square? Summation of x times p of x. That is just the expectation of x. Quantity squared. So, pwede ra na kani ang atong introduce sa ato ang mga bata. Kani, expected value of x squared minus kani silang duha kani. Kay kani, later on, pag nanatay table, mo man ni ilahang gamiton pag-compute. So, kung imo ra ilaha din itong i-add, mo na din to siya si expected value of x squared minus the expected value of x quantity squared. So, pwede ra kana ra itong i-introduce sa ato ang mga bata. Okay? So, sa atong previous example, kung ang ato ang random variable, ang experiment and the random variable is the sum of the upturned phase, so we have the expected value or mean of 3.5. So ang iyahang expected value nga gi-square is 3.5 squared, that is 12.25. So para sa expected value of x squared, we have si x gi-square nimo, so 1 squared times 1 over 6, 2 squared times 1 over 6, 3 squared times 1 over 6, plus 4 squared times 1 over 6, and so on. So you will get these values. And the sum na equal to 91 over 6 or 5 over 17. Okay, ingon ana ra siya. Okay? So therefore, the variance of the discrete random variable is 2.92. Kay kadtong ato ang previous nga 12.25, di ba? Mo man ni siya ang sa second nato nga kuan, mo ni siya ang gi-subtract. Ang gi-subtractan 15 over 15.17. So 15.17 minus 12.25, that is 2.92. So that is now our variance. And note that the variance measures the spread or determines the degree to which the values of a random variable differ from the mean or the expected value. So it's your turn. What is the variance of x given the probability distribution below? Sige daw, be. Kamo, and then pick your answer from the choices. Let me launch the poll. Okay. So ang value ay ang iyahang formula, di ba? Expectation of x squared minus the expectation of x quantity squared. So you get first the expectation and then get the square and then subtract it from the expectation of x squared. Okay, choose your end of the poll. Okay, so 33 na ang nag-answer. 34 out of 52. Okay, let's have 20 seconds more. Okay, so let's end the poll and share the results. Okay, so 86% or 32 participants answered 0.64, while 3% answered 0.54 and another 11% answered none of the above. Okay, so what is our answer now? Correct answer is 0.64. So using the formula, kadtong expected value of x squared, sorry, wala na ko na-include ang iyahang solution, but the answer is 0.64. All right, so let's have another example. Dr. Makelele, in preparation for the new mode of learning in the upcoming school year, asked the enrollees in his class on the gadgets that they own. The random variable x represents the number of gadgets the students own. The probability distribution of x is shown below. So, mo ni siya, the probability of x equal to 0, 0.23, 1, 0.45, 2, 0.18, and 3, 0.14. Now, we can use a table para guide sa ato ang students in computing the mean and the variance. Okay, di ba? Medyo mas lisod-lisod kung ingato o nato pag-present lang. So we can supply them a table. Okay? So ingon ani ang iyahang itsura sa table. Mas okay siya kay nakabutang na daan, igo na lang nila ipang type diri as a table kung unsa ang mga values. Okay? So we have x is equal to 0 and p of x is equal to 23. So kana siya na siya daan kay mo maning nasa tong probability distribution. Kaning remaining nga mga blanco diri amo lang ni siyang atong i-supply. Okay? Gusto ta na ako nga kamo ang mo answer ani, i-annotate bitaw ninyo nga pwede nato i-type. But I guess we only have 8 minutes left. So ako na lang ihatag ang answer. So 0 times 0.23, we have 0. 1 times 0.45, 0.45, 2 times 0.18, 0.36, 3 times 0.14, 0.42. And for x squared, that is just to get the square of our random variable. So nakay, by the way, pag isum na nato siya, muna na siya ang atong expected value of x, di ba? Muna na siya atong mean. So x times p of x, kwaon na nato sila tanan, ang sum ana niya, muna na atong expected value of x. And for x squared, we have 0 squared, 0, 1 squared, 1, 2 squared, 4, 3 squared, 9. And for x squared times p of x, so imo ra siyang i-multiply. So we have 1 times p of x, 0.45. So 0.45. 4 times 0.18, 0.72. 9 times 0.14, 1.26. And if you get the sum of this, that is equal to 2.43. So natay expected value of x squared na po the expected value of x. Ato na dahil silang isubtract si 2.43 kang 1.23. So that means ang variance nato is equal to kani siya mean naman ni siya daan. So ang variance nato is equal to 2.43 minus 1.23, 1.51, which is equal to 0.91. Okay. So the mean is 1.23. Moreover, the variance is 0.92. So what does this mean? So may pasabot ani. That means that if we look at a large number of students, dili lang kay ta mag-concentrate dito katong pila lang ka kuan. Kung suppose atong dagkuon ang number of students, daghanon nato, kuha na pud tag isa ka student, dungagan na pud nato. On the average, ang kada student will or kada estudyante owns 1.23 gadgets. Wala may 0.23 no, pero usually kung unsa mo na compute nga mean, mo na siya ang iyang mean. Pero in other words, you can say 1 or 2 gadgets. Hindi naman siya sa tunga ni 1 or 2. Alright? And the variance 0.92 now measures the spread of the probability distribution. Alright? So sige, let's have some real life problem. Robinson's Mall, kay kuan man daw ron, COVID, is limiting alcohol purchases to a maximum of 4 alcohol bottles per customer. Let X be the number of alcohol bottles purchased by a random customer. So muna siya ang iyang probability distribution ni X. So probability nga ang customer mo purchase og isa is 0.1. Probability nga ang customer mo purchase og duha 0.3. Probability nga ang customer mo purchase og tulo 0.2 and so on. So ato dang i-compute ang expected value of variance. Right? So kana nasud siya nga table. So 0.1 times 1 same, 0.3 times 2 same, 0.60, 0.2 times 3 0.60, 0.4 times 4 0.60, and the sum of these values is equal to 2.9. X squared 1, 4, 9, 16. X squared times the probability, so 1 times 0.1, 0.1. 4 times 0.3, 1.2. 9 times 0.2, 1.8. 16 times 0.4, 6.4. Get the sum, 9.50. So kani kinsa ni siya, mean ni siya nato. Ang sa variance, gamito ni nato minus square ani niya. So for the variance, so ang atong expected value or the mean is 2.92. Ang variance nato is 9.5, which is our expected value of x squared, minus 2.9 squared, which is 8.41. So we will have 1.1. Last na lang yun. Question ako, what does this mean? Can I ask a participant this time? Say pasabot ana, Sir Jeremiah, unsa day pasabot ana kung ang iyahang, can you unmute Sir Jere, Maya, Atenta? Pwede ka mag-unmute, sir. Sir Rem. Sir, unsay pasabot? Hi, good morning, sir. May udto diha. So unsay pasabot nato ani ron kung ang mean niya is 2.92 and variance is 1.01. Sir?
Hello?
Yes, sir. Sige daw, sir. Ibalik daw, sir.
Ibalik daw po sa kuan ma'am, problem.
Unsay... okay. Sige daw. Okay. So, di ba ang mean niya is pila to?
2.9.
Okay. So, unsay pasabot ana ron kung ang iyang expected value is 2.9?
So the long run average of
Ano mo, choppy man si Sir Jeremiah, no?
hello?
Mm,
Makaro ko, ma'am.
Sir, mukarat imuhang tingog, sir, pag mo answer.
Hindi ko internet, ma'am. Mag-disconnect ko.
Sana lang gid kaha ning atong mga estudyante puhon. Sige na. So kung magkuha pa ta og kung daghanon nato ang ato ang customers, then
the average number of alcoholic bottles per case is 2.9.
Okay.
2.9.
Correct, Sir Jeremiah. Salamat kayo, Sir Jeremiah, ha? Salamat gid kaayo ha, miski struggle ang internet connection na gihapon ka. Okay, so that's all for my discussion. I hope nasugakod ra ninyo. And for my references, mo ni siya. And that's all for random variables and probability distribution. Thank you for participating, and to God be the glory. Thank you. Just in time kaayo oy, gabi pag alas.
Okay, so ma'am, pwede stop share para maka-share screen ko, ma'am. So at this point, since we're running out of time, we will entertain one question from the audience. So please drop your questions in the chat box. So if there's none, we'll proceed with the announcement. Questions? If there's none, we will proceed. Okay, so we'll proceed with the announcement. So please log in to your LMS account to access the assessment and evaluation, and so with your certificates. So please be advised to check or change your profile at the CSU Learning Management System or LMS account before completing the task. So the name you registered in this platform is the name that will appear on your certificates. So the completion of the lecture, assessment, and evaluation for each webinar is time-bounded. So you are only given until midnight of the conduct of the webinar to complete this. So access to these activities will automatically be disabled beyond midnight. So for more updates, follow us or follow the CSU Extension e-PASA page. Okay, so for tomorrow, our speaker, Sir Briggs Michael Agua, will talk about techniques and strategies in teaching the normal distribution. So before we conclude the webinar, may I request everyone to please turn on their videos for a class picture. Okay. Okay, wait lang ha. So please turn on your videos. Stop share. Oh, sorry. Stop share. Okay, so next. Everyone, please turn on your videos. Smile. Okay, next. Smile sa amo diha ha, kay nag-capture pa ko. Smile. Smile. Okay. Okay, so that's it. Thank you so much. So once again, we would like to thank everyone for your active participation and staying with us all throughout the webinar. This is CESU e-PASA Lectures 2020 webinars on techniques and strategies in teaching statistics and probability. Okay, so pwede na tayo mag-leave and proceed to your LMS for the evaluation, assessment, and your certificates.